Hello and welcome back to the podcast. Now, today we're diving into a brand new subject, and I'm quite looking forward to this one.
Really?
Yeah.
Oh, okay. I wasn't expecting that. You're throwing me a bit. So I'm going to start off with a question. Who invented
Okay.
the television?
Um. Okay, this is going to make me sound silly.
You
Because it
never worry
wasn't
about
it
that.
wasn't just one person. Oh,
Yeah.
don't expect me to remember names. So there was an American, and there was a
Yeah.
Scottish guy.
Yeah. Yeah. So you already know, so we can end the podcast here. Goodbye. Anyway,
Didn't know the
we
names
can
there.
edit it. Yeah. So the Scottish guy, as you put it, would be John Logie Baird,
That's
which
it.
is
I knew that.
that's, that's exactly what most people would say,
Mm,
especially in the UK.
yeah.
But the reality of it is far more complicated, and I'm going to argue that he didn't actually invent the television that we know and use today.
Right.
And to understand why, we have to go back long before Baird, to the Victorian era. And
Oh.
this, yeah, the dream they had of seeing afar is an old one, but it was
Mm.
Victorian physics and electrical engineering that provided the actual building blocks for what we know as television.
Oh, okay. So the technology that made the television was being developed before anyone even thought of the word television.
Mm.
So
Yeah.
where did this science actually begin then?
So it started with a very important, a very critical breakthrough in 1873 by a man named Willoughby Smith, and
Right.
he was testing materials for a transatlantic telegraph cable, and he discovered a property called photoconductivity in this element called selenium.
Photoconductivity. I've heard that
Photoconductivity.
term, but just for our audience, what does it actually mean?
Oh, thanks. So it basically it's the a phenomenon.
I can never say that word.
It's like to say I don't know when we move on. Basically, it's this thing where a material becomes a much better conductor of electricity when light shines on it. And in
Right.
the case of selenium, when it's in
Okay.
the dark, it has high resistance and blocks electrical current. But the moment light hits it, its resistance drops and allows more current to flow.
Oh, okay. So the strength of the electric current changes depending on how bright the light is.
Exactly, yeah. So
Right.
it meant you could finally translate the varying brightness of an image directly into a corresponding electrical signal that
Oh,
would be able
right.
to travel over a wire. But that led to quite a large problem, actually. How
Mm.
do you make a whole image made of countless points of light and shadow and squeeze it into a single transmittable electrical signal?
Right, because the wire or a wire can only send one electrical impulse at a time, I'm guessing, but a
Yeah.
picture is a whole canvas of information all at once. Yeah, that's quite a predicament. How did they solve that?
Well, they come up with a principle known as scanning, and the idea was to dissect an image into individual lines or points,
Right.
convert each point into an electrical signal sequentially, transmit them, and then reassemble them in like perfect synchronization at the other end.
Oh, okay. So like reading a page of text line by line, but doing it fast enough to fool the human eye, in a sense.
Yeah, yeah,
Okay.
spot on. Yeah, that also relies on something called persistence of vision. So that's where our brain's tendency to retain an image for a split second after it
Yes.
disappears.
Yeah.
Yeah. So if you present a rapid succession of still images above roughly, I think it's 16 frames per second, the brain merges them into smooth, continuous movement.
Like the flick book things.
Exactly like flipbooks or film.
Yeah.
Oh, what we think of as
Yeah,
film.
yeah, yeah.
Yeah.
So who actually built the first device to do this scanning?
So that was a German inventor named Paul Nipkow, and he did it
Right.
in 1884. And he he patented what he called an electric telescope, which
Okay.
featured what is now famous in this area as the Nipkow disc. And oh dear, I've got to explain this now. So it was flat, circular disc with a spiral pattern of small holes in it. So as it spun, each
Okay.
hole would pass across a segment of an image, and that would let light pass through it to a light sensitive cell line by line. And at the receiving end, the other end, a second synchronized disc paired with a light source would put the image back together.
That sounds very complex, but
If you
basically,
saw it, sorry, if you saw it, it'd make perfect sense. It's hard to just,
yeah. Okay, so basically, it was a mechanical wheel with holes in it.
yeah.
So did Nipkow actually get it to work?
So he he never built a fully working system, but the disc became like the foundation for all mechanical scanning.
Right.
Now, while this mechanical path was opening up, there's a parallel development happening in Germany. So in 1997, there's a fella called Carl Ferdinand Braun, and he
Right.
invented the cathode ray tube.
Okay, now what you have to explain what is a cathode ray tube?
Now, it will mean more to the older listeners, but
Right.
it's essentially a evacuated glass tube, which means all the air has been pumped out of it to create a vacuum, so nothing interferes with what's happening inside it. And inside this tube, an electron gun fires a beam of electrons through the empty space. And by
Right.
using magnetic or electric fields, you can
Mm.
manipulate that beam, steering it so it strikes a phosphorescent screen at the front, which creates like glowing spots.
Okay, so hang on, I have to visualize. So it's like
Um,
a
like, um,
glass container with a vacuum inside, and you're using magnets to aim a beam of light at the screen.
yeah,
So Braun built this to display electrical waveforms, but other scientists would have seen its potential to display images, I imagine.
yeah, definitely.
Right.
So, but by the time we get to the end of the Victorian era, we have two completely different sets of technologies.
Mm,
You've got Nipkow's mechanical spinning disc and Braun's electronic cathode ray tube.
okay.
And these two inventions set up like a huge crossroads, really.
Yeah.
And they formed two entirely distinct paths for early television development, the mechanical systems and electronic systems. And
Right.
it was the race between these two systems that would decide who truly invented television.
Oh. So, how did inventors take these raw Victorian components and actually turn them into a working device?
Because they're smarter than us, really. I think is the first answer.
Obviously
Yeah,
they are. And they didn't have
yeah,
Google
yeah.
then either.
No, I don't know how they managed that, Google.
Mm,
Anyway, they did it through a wave of early pioneers scattered all over the world, each of them contributing like vital blueprints and experiments. And it's important to realize that television wasn't the product of a single mind, it was
mm.
like a huge jigsaw puzzle being put together by scientists across multiple, not just geographies, but disciplines as well.
All right, that's really interesting, and it's quite nice. I don't know if nice is the right word, but that there was this sort of mass input rather than it just being like one inventor. But
Yeah.
where does the story move next after the Victorian era then?
Okay, so one of the earliest conceptual ideas actually came from France in 1880, and there
Right,
was an engineer named Maurice Leblanc, and he published a paper outlining how you could analyze an image point by point and line by line.
right,
His ideas were they were just theoretical. He never built
right.
it, but he essentially gave the scientific community the first real explanation of how visual information could be electrically transmitted.
Oh, okay. So he gave them the theory, but someone still had to figure out how to build the hardware.
Yeah, exactly. And that
Okay.
then brings us to another Scottish, like an electrical engineer named Alan Archibald Campbell Swinton, the most
Oh,
Scottish named person I think I've ever heard. And
yeah.
in 1908, he wrote a letter to the journal called Nature, and by 1911, he laid out a radical, not prophetic vision, which was a completely electronic television system.
Completely electronic, so
Completely
no
electronic.
spinning wheels or moving parts at all.
No, none whatsoever. And he
Okay.
proposed using this cathode ray tube at
Okay.
both ends, one at the camera side to capture the image and one at the display side to show it. And
Okay.
he theorized that a mosaic of light sensitive elements inside the camera tube could be scanned by an electron beam to convert the picture into an electrical signal.
Right.
Then a second synchronized cathode ray tube would use another electron beam to recreate the image on a screen.
That sounds exactly like how television eventually ended up working. But did he actually build it?
No, he didn't know. The technology needed to physically, the technology he needed to build it was still decades away.
Right.
But it's like Campbell Swinton's unbuilt system provided a roadmap that heavily influenced the people who would eventually build it.
Okay.
So then we go. Meanwhile, over in Russia, there's this scientist named Boris Rosing, probably not pronounced that way, but
No.
he was actually trying to build a hybrid system.
Oh, how would a hybrid have worked?
Well, I have no idea. No, can't really leave it like that, can I?
No.
In 1907, Rosing conducted experiments using a mechanical mirror drum to scan the image at the transmitting end, but he used a cathode ray tube as the receiver to display it. And he
Right.
actually managed to transmit crude, like geometrical shapes onto the screen, which makes him one of the very first to prove the cathode ray tube could work for television.
That is a pretty huge step forward.
Oh, it's massive, isn't it? Yeah. And it was Rosing's work was particularly important because he had a student who was watching all this very closely, and that's a young man named Vladimir oh, I knew this would happen. Vladimir Shorokin. Right, I should have looked this up, shouldn't I? Shorokin.
You should have looked up
Anyway,
how to pronounce it.
yeah, Vlad, who he would later become a giant in electronic television.
Right.
It's just a shame no one can pronounce his name. But while
No.
the electronic side was brewing, mechanical television was still moving forward as well, especially in America, where it was with a man named Charles Francis Jenkins.
So Jenkins was the American equivalent of John. I can't pronounce his name. I'm just going to
John
say
Logan
John Bard.
Baird.
Is it
Yeah. So
Baird?
definitely, yeah. And Jenkins focused on transmitting images wirelessly, which he called radio vision.
Right.
And yeah, in 1923, he achieved the first witness demonstration of moving images, which were transmitted wirelessly, and he used a system of it was called prismatic discs to scan images.
Prismatic discs. So what are those exactly?
You'd ask. So
Of
think
course.
of
Testing.
think of a very think of mostly my patients. Think of a glass
Mm.
disc where the edge isn't flat, but it's shaped like a series of tiny prisms.
Okay.
So as the disc spins, these prisms bend the light passing through them at changing angles. And
Right.
this allowed Jenkins to guide a beam of light across a camera sensor or a screen, scanning an image line by line without needing a disc full of actual holes like Nipkow's disc. And he eventually used this method to start selling mechanical television kits by mail.
Television kits by Mal in the
Yeah,
1920s.
yeah,
Now that sounds really ahead of its time.
yeah. Oh, amazingly, massively ahead of its time. So
Yeah.
by 1928, Jenkins was granted the first commercial television license in the States, broadcasting radio movies from an experimental station near Washington, D.C. And now this mechanical system ultimately suffered from the exact same limitations in picture quality as Baird's did, but he was vital for getting the public excited and launching early broadcasting.
Okay, so by the 1920s, you have inventors in America, Russia, and the UK all
Yeah,
racing down these two different paths. You've got the mechanical and the electronic.
yeah, definitely.
Right,
Um, so that this sets the stage for a massive technological showdown, and
right.
the theories had been proven. The public was interested, and now it was a race to see who could actually demonstrate the first complete commercial system.
So that brings us right back to the man we started with.
It
So
does.
how did Mr. Baird, I don't know if I said his name right again,
It's perfect. Yeah.
did I? Oh, okay. Step into this global race. How did
So
he?
so Baird enters the frame as a man of absolute unyielding determination. He was born in Scotland in 1888. He was a trained electrical engineer who became utterly obsessed with achieving this seeing at distance.
Right.
But unlike some of the heavily funded laboratories elsewhere, Baird was working out of incredibly modest surroundings, most famously in an attic lab in Soho in London.
Oh, okay. So he's your classic underdog working on a shoestring budget.
Oh, entirely. It
Right.
was, in fact, his early experimental setup is really famous for being held together by like, everyday household
Oh,
objects.
really?
Yeah, so to build his first televisor apparatus, he used an old hat box, a tea chest, darning needles, and lenses from bicycle lights.
Oh my
And
God.
he combined those with a spinning Nipkow disc, a selenium cell to catch light, and a neon lamp to project the image at the other end.
A hat box and a hat box? A hat
Hat box,
box
yeah,
and bicycle lights.
brilliant.
That's pretty amazing. It reminds me of when you were a kid and you'd be playing make believe and you'd just get random objects in the house, but you could use them to pretend that to set a scene or something. Or do you know what I mean? I don't know if you do know what I mean, but it
I used to
reminds
use
me
them to
of
make television.
that kind of resourcefulness. But did it actually work well enough to show a real image?
It did, yes, but it was incredibly crude.
Right.
If you go online and Google Baird's televisor,
You can
you
probably
you probably be
find
able to
it.
see the images.
Yeah.
So the selenium cells he used weren't very sensitive, and the neon lamps were quite dim, meaning he had to blast his subjects, whoever's being filmed, basically, with blinding, intensely hot lights, just to get the equipment to like register a shape. So in October 1925, he actually managed his first successful test with human features,
Wow.
and he used his 20-year-old office boy, a fellow called William Edward Tainton, who later recalled just how terrifyingly hot and bright the studio lights that he used were.
I can imagine. But he didn't just keep it in the lab, did he? He went public.
He did, yeah. He he did, and this was what cemented his fame. So on the
Mm,
26th of January 1926, Baird gave the world's very first like public demonstration of a true television system, and he invited members of the Royal Institution and a reporter from the Times to his lab in Soho, and he showed them live moving pictures. But he used a ventriloquist dummy nicknamed Stooky Bill, which is a
oh,
crap name. I don't
okay.
know what it means.
Stooky Bill.
Yeah,
Um,
yeah.
what did the audience actually see on the screen?
So what they saw was a tiny monochrome flickering image. It was just 30 lines of resolution,
Right.
which by comparison, a modern standard definition TV has like 576 lines, and a high
Okay.
definition one has over 1,000.
Wow.
So it was incredibly blurry, but it undeniably showed live movement and shading, and it was a
Oh, wow.
monumental moment because it
Yeah.
proved to the world that television was no longer science fiction fancy; it was real.
Okay. So Baird has successfully grabbed the headline, but
Yeah.
where did he take the technology from that point?
Well, he really pushed it as far as it could humanly go.
Mm,
In 1927, he transmitted a television signal over 700 kilometres between London and Glasgow using the telephone lines.
right.
In 1928, his company achieved the first transatlantic television transmission, and they sent an image from London all the way to New York. And he even demonstrated a prototype for colour television in 1928
Wow.
by he used spinning discs fitted with primary colour filters.
Okay. It sounds like he was completely dominating the field.
Yeah.
But did the broadcasters start taking him seriously?
Oh, yeah, definitely they did. So it come to 1929, and the BBC actually partnered with Baird to launch experimental television broadcasts.
Okay.
And it was the absolute inception of public television services, with the first handful of early adopters buying Baird's televisor sets to watch at home.
Do you know, this sounds like a complete triumph. And so this is what I mean. If he had the BBC on board, he had the first public broadcast, and he had transatlantic success.
Yeah.
How can you argue that he didn't invent television?
Well, we need to make a very important distinction. And I would argue that John Logie Baird invented the televisor, which was a brilliant piece of mechanical engineering.
Mm,
But television, as we know it, the technology that went on to change the world was based on the cathode ray tube. And
right.
Baird had hit a brick wall. He had perfected a mechanical system, but mechanical television was an inherent technological dead end, and you
Okay.
simply couldn't get a high quality detailed picture out of a spinning disc. It was physically limited to about 30 lines, and on top of that, the spinning wheels made a loud constant whirring noise, and the cameras required such fiercely hot lighting that it was completely impractical for a proper television studio.
Oh, okay. So the mechanical system was basically maxed out, and now the
Yeah,
public want better quality.
definitely. Yeah. So the world needs a system with no moving parts, no loud vibrations, and a crystal clear picture. So
Right.
whilst Baird was trying to make his spinning discs go faster, an entirely different race was reaching its climax, which is the race for the fully electronic television.
So who was actually building this silent electronic alternative that would eventually replace Baird's invention?
Now, so this is the person I say invented television. The future was being born across the Atlantic in the mind of a young American visionary named Philo Farnsworth. And he
Okay.
was born in Utah in 1906. And Farnsworth, he was a self taught technical prodigy. So even as a
Okay.
teenager, he looked at mechanical scanning systems and knew they would just hit a brick wall. They weren't going anywhere.
So how when you say a teenager, how young are we talking, and when did he get the idea to change things?
So amazingly, the inspiration hit him when he was 14.
Wow.
Now the story goes that he was ploughing a potato field on his family farm, looking back at the neat parallel rows he had carved into the earth, and it suddenly struck him that an image could be sliced up and scanned in the exact same way, line by line, row by row, but using electricity.
That's amazing that a teenager on a
Yeah.
tractor could figure out the future of global media. But how did he actually turn that idea into a piece of hardware?
Once again, because he's smarter than we are.
Yeah, clearly.
Yeah. Well, his core innovation was a device called the image dissector tube. So unlike Baird's system, which needs
Mm,
this physical spinning disc to chop up the
mm.
light, Farnsworth tube was designed to capture and convert an entire image into an electrical signal purely electronically. And by 1926, he secured financial backing from a couple of philanthropists
Mm.
to set up a laboratory in San Francisco to try and build it.
Oh, okay. So he's working on the first fully electronic camera tube. Did he manage to get a working picture?
He did. So
Oh,
on 7th of September 1926, when he was 21, he successfully transmitted the first all electronic television image in his lab.
oh, okay. What was it? Was it another dummy?
No, simpler than that. The very first image was just a straight line.
Oh,
But
okay.
yeah, not long after
Keep
that,
it simple.
Yeah, and not long after that, his investors, who were naturally keen to see if their money was going to pay off, asked him to transmit something else. So he transmitted the dollar sign.
Oh, brilliant.
Yeah,
That's brilliant. Yeah.
yeah, it's quite symbolic. It
Yeah.
came through perfectly clear on the receiver. It completely solidified the investors' belief in the commercial potential for this machine.
Yeah.
And it proved beyond doubt that you could scan, transmit, and recreate images using nothing but electron beams, no mechanical parts required. And he filed a patent for his system that same year. But that is where his trouble started.
Yeah, I can imagine because once you prove something that valuable works, I bet everyone wants a piece of it. So who came after him?
Now, the biggest, that was the biggest fish in the pond, and that was the Radio Corporation of America, known as
Mm,
RCA.
right.
And they were a massive giant in the radio industry, and they were they were led by a ruthless businessman, which was a fellow called David Sarnoff. And
Okay.
so RCA had their own electronic television research division led by Vladimir Shroikin,
Oh,
that
okay.
Russian scientist we
Yes, you
mentioned earlier.
mentioned
Yeah,
him earlier. Yeah.
yeah, I'm actually quite confident with the way I pronounce his name then. But
Oh, yeah.
when when RCA realised this independent young fella in San Francisco held the keys to electronic television, like a brutal multi-year patent war erupted.
I can imagine that they would have had an army of lawyers as well. So how did
Yeah.
Farnsworth stand a chance against such a massive corporation?
Well, he had a secret weapon, which was his down to meticulous documentation. So, crucially, his old high school chemistry teacher actually came forward with a drawing Farnsworth had done on a blackboard as a 15-year-old boy, proving that he'd come up with the electronic scanning concept first.
Oh,
And then, yeah, mad. In 1934, the US Patent Office ruled decisively in Farnsworth's favour, and they named him the undisputed inventor of electronic television.
wow.
And RCA was forced to bow down and pay him royalties.
So that's a classic David and Goliath story.
Love it,
But
yeah.
so he won the legal battle, but did he get to enjoy the success?
No, not really. So the years of intense litigation, the endless stress and non-stop lab work took a huge toll on his health and his finances.
Mm.
So although his company did manufacture some of the very first television sets after the Second World War, it struggled to compete commercially and was eventually bought out.
That's quite tragic, actually, considering it was his technology that became the foundation for the entire modern world.
Yeah, it is, yeah. But his legacy is monumental.
Mm.
Um, so while Baird's mechanical televisor captured the public's imagination first, it was Farnsworth's lightning fast manipulation of electrons that actually gave us television as we know it. And he
Yeah.
proved that the future of sight wasn't mechanical, it was electronic.
So Farnsworth had proven it could be done independently in a lab,
Yeah.
but how did this electronic system actually get out of the laboratory and into the homes of millions of regular people?
By people who are much smarter than us knowing what they're doing.
Yeah.
Yeah. Well, anyway, so this is where the story shifts from the independent inventor to the corporate heavyweight. So
Mm.
while Farnsworth was working alone in San Francisco, you had this brilliant Russian physicist, an engineer called it like the Vladimir Shroikin, and he was attacking the problem with the backing of massive industrial power.
Right.
So as we mentioned earlier, he had um, a significant head start because he had studied directly under Boris Rosin during these
Mm.
early cathode ray tube experiments in Russia.
Yeah, he was the student who was watching Rosin's mirror drum and cathode
That's
ray
yeah,
tube setup very closely.
that's him.
That
Yeah.
was him, yeah.
So yeah, so he emigrated to the States in 1919, and he was determined to make electronic television a reality.
Mm.
So now, where Farnsworth had his image dissector,
Mm.
Droykin developed his own twin inventions that would form the electronic camera and the display. So there was the iconoscope camera tube and the kinescope picture tube.
Okay, you need to break those down for
Oh,
me. What did the iconoscope actually do?
I've no idea.
You should know because you're the one who's researched this.
Yeah. So the iconoscope, which he filed a patent for in 1923, while working for the Westinghouse Electric Company, it was basically television's first electric eye.
Okay,
So inside the camera tube, it used a photosensitive plate covered in a mosaic of tiny light sensitive sections. So when you
okay,
pointed the camera at a scene, the image was projected onto this plate. Then
right.
an electron beam, you getting this so far? Then
Yeah,
there was an
kind
electron
of.
beam scanned across it, and each tiny section released an electrical charge proportional to how much light was hitting it.
Okay, so in a nutshell, it converted a visual image into an electrical or electronic signal.
Mm.
Okay, what about the kinescope?
That's what I'm going with, kinescope. So
Kinescope.
that was developed in 1929, and
Okay,
it was just a very like, highly improved cathode ray tube designed
right.
specifically to be the receiver. And it took that incoming electrical signal and used an electron beam to paint it back onto a fluorescent screen. So it turned the electricity back into moving pictures. So together,
Okay.
the iconoscope and the kinescope gave you a complete electronic loop, the electronic eye to see it and the electronic screen to display it.
That sounds incredibly sophisticated. But
Yeah.
how did a corporate giant like RCA, for example, get involved with him?
So Zworykin's brilliant work caught this attention of that David Sarnoff, the head of the RCA, and
Okay.
he was Sarnoff was a visionary businessman who ran American radio, and he knew television was going to be the next empire and the next big thing.
Okay.
So in 1929, he hired Zworykin to lead RCA's electronic research lab and gave him practically unlimited financial and scientific resources to perfect this system.
So this is the team that went to war with Farnsworth over the
Yeah,
patents.
yeah,
Right.
definitely. Precisely.
Okay.
So RCA used Roykin's work to challenge Farnsworth. And even though the Patent Office ultimately ruled that Farnsworth had the legal priority for electronic scanning, RCA was so massive and powerful that they just paid Farnsworth his royalties, took the technology, combined it with what Zworykin had done, his designs, and used their immense commercial muscle to take over the market.
So Farnsworth invented the underlying legal blueprint, if you like, but
Yeah,
RCA and Joykin actually built the commercial machine.
exactly.
Right.
And yeah, they bridged that gap between a lab experiment and mass consumer product.
Okay.
And the grand climax of this happened in 1939, like the 1939 New York's World Fair. And
Okay.
RCA made a massive public debut, broadcasting live television and selling consumer sets right there on the pavilion. And it's widely considered the official launch of regular electronic television broadcasting in the US.
Wow. So by 1939, electronic television was officially out of the bag in America and it was backed by corporate millions.
Yeah, yeah. So the mechanical system, it didn't stand a chance. Zworykin's practical engineering combined with RCA's industrial power set the technological standards that would govern television for the next 70 years. And it brings us right back to our original point. John Logie Baird's mechanical televisor was a spectacular achievement for the 20s, but it was the
Mm.
electronic system perfected by Farnsworth and commercialised by Zworykin and the RCA that actually became the television of the modern world.
So, talking of the modern world, when did flat
Yeah.
screens appear and replace the cathode ray tube?
It, okay, so that sort of happened a lot later than most people would realise.
Mm.
While scientists were experimenting with flat panel technologies like the old liquid crystal displays, LCDs, and plasma screens, as far back as the 1960s, the cathode ray tube was cheap, it was reliable, And it was the powerhouse that it absolutely dominated the market for decades.
Right. So when did the scales actually tip?
Okay, well, that wasn't until the early 2000s, so around 2003 to 2005, that the manufacturing costs for flat LCDs and plasma panels dropped dramatically. And while their picture quality soared as well. But for the first time, consumers could buy a massive, lightweight screen that could hang on a wall, completely doing away with the deep, heavy glass boxes that I remember,
them.
and
Yeah.
that had ruled living rooms since the days of Braun and Zworykin. So by roughly 2007, flat screens officially started out selling cathode ray tube televisions globally, and it brought an end to that tube era.
It's funny because I can't imagine life without flat screens now, but I didn't grow up with flat screens. And even when my
No,
husband and I bought our first flat, that would have been about 2006, we had the old, we didn't have a flat screen telly. We didn't have a flat screen telly for probably quite a few years after we
yeah,
moved. But yeah, but now you just cannot imagine it. It just seems so dated.
yeah,
But anyway, we've reached the end of the podcast. So that was interesting. And thank you very much for that.
a pleasure. Thank you for listening.